Okay, so welcome to my video. I am demonstrating my requirements for my senior project. Today, what I hope to be able to do is to demonstrate my must-have requirements or my base requirements. So, to give a little background, I am doing license plate recognition with a focus on image processing. So what my project specifically is, I am going to take a cropped image of a license plate, and I am going to do all the pre-processing necessary in order to toss it over to an OCR engine. And hopefully the pre-processing I do is good enough to get 80% accuracy, which for most license plate is about one character off. Which would 80% is 4 out of 5. But most license plate numbers have 6 or 7 characters. So I limited my scope to these 5 states because what I found during my project and doing research and creating some test code is that what each image needs is very different based off of what it contains. There can be a lot of differences between, serif and sans serif. I know Virginia uses a particular font that is very different from most states, and it makes it a little more difficult. And we'll see some examples as I go throughout this, but these states, for the most part, all have very similar characters, and they have lighter backgrounds and darker text. So it makes it a lot easier. So I'm going to, or for success for this requirement, I need to be able to get those 5 states at above 80% accuracy. So to demonstrate this, I will show a variety of crop plates and run it on my project to get the plate number from the image. And I should be able to do that with above 80% accuracy. So basically what I'm going to do is, as I run through my project, I'm going to show, or I'm going to keep track of the number of characters that I miss and divide that by the total number of characters that I even attempt to recognize. And so what that percentage should be is it should be under 20%. So let's go ahead and get started. I'm going to go ahead and minimize that. This window over here will have the count of the number of missed characters for me, and I'll be running my project over here, and I'll be showing you some rough pre-processing and what I'm doing behind the scenes over here. But to go ahead and get started, I feel like I need to prove that I am only using the OCR engine for what I intended it to do. And I'm not using it for any more than literally just recognizing the character in an image. So I'm going to open up my editor, and I have this line uncommented, which removes an OCR directory in my home directory. And what that image contain, or what that directory will contain, is a bunch of images. The individual binarized character of that image that I literally just hand it off to the OCR engine and have it detect it. So let me go ahead and show that. So here's my home directory on the left hand side, and on the right hand side I'm going to go ahead and run this. So it's going to run it on California. It runs it. Okay, that's great. This pops up. What I initially do is I just say, hey, I'm going to do some cropping so I don't have to worry about a bunch of extra crap that I don't need to worry about. And then I do some blurring, some noise reducing, some thresholding, and then I do another step of reducing some binary noise. And that's all great. And lo and behold, this OCR directory was created. And what that contains is all the different characters. Just a single image, and the way that I chose to do it was to use Tesseract, which is an OCR engine. And it's unfortunate that I couldn't do it the way I wanted it to, but Tesseract requires an input image, and then it kicks out the output in a text file. And so I had to, instead of keeping everything running in my program in memory, I unfortunately had to write to disk, which slowed down my program quite a bit. But it's only for California plates, it's only 7 characters, so it's not that big of a deal. And this is more proof of concept anyways. So, yeah, that's what I'm doing. I'm doing all my pre-processing. I'm going to go ahead and delete this directory because that's what my program normally does anyways. And I'm going to uncomment that line. I'm going to close out of this, stop that, clear it, save that. And I am going to show you the variety of plates that I have. So if I go over here to my senior project, go to some state plates, here are the 5 states: California, Connecticut, Maryland, Massachusetts, and Nevada. I have 5 plates, and they're all different plates in each folder. And it's going to go through and it's going to read these in, do my pre-processing on it, and toss it over the OCR engine and kick out the license plate number. And as I stated previously, I'm going to try to do my best to keep track of the number of characters that I miss. Now, if I counted right, there's 154 characters. So we have 35 here because there's 7. Oh, we have 34 here because that's only 6. And then we have, let's see if I can do this. 34 plus 5 times 6 is 30. And each one of those has 6, so that's another 30. And 1, 2, 3, 4, 5, 6. This one only has 5. So that one was going to be 29. 6, 6, 6, 6, and 6. So that's another 30. Have eLisp evaluate that for me. So I was off by 1. It's 153 characters. And if we did that times 0.2 and evaluate that, that means I have to be under 30 characters wrong. I have to be 30 or under. So here's what I'm going to do. That 0 up on top is going to be my count of the number of characters. And if that exceeds 30 at any point, that means I am below 80%. So let's go ahead and get started. I believe everything is all set up and ready to go. So let's run through these 25 images. So running California first. This one is all correct. So it's still at 0. PIN. So this one got one wrong. And that's what I found. A lot of the time the OCR engine would actually miscategorize the characters the same ways. O's are usually categorized either as U's or I's. And in this case, it was an I. And this one missed 3. It got the E750 right, and it messed up on the first 3 characters. And I think it's because the California 4 is a little weird. I'm surprised that it missed that N, but it struggles with the O's, so I'm not surprised that it categorized the Q as an I. So that brings our total to 4. Uh, 6JIV337, that is correct. And this last one it got correctly as well. Oh, there is an E on the end of that. Oh, never mind. That is correct. Okay, so moving on to Connecticut. It missed the 1. It thought it was an I, which is understandable. And the O, it also thought was an I. So that's another 2 to bring to 6. Moving on to the second Connecticut. Sample is correct. Uh, 879 UYP is correct. 574 KTE is correct. 807 HHZ is correct. SAM I39 is incorrect. It missed the 1 again. So that brings our count up to 7. So this one missed the M. Now, I know it looks like that it may have categorized the M as an open bracket and then this little weird looking character as a U, but that's not what it's doing. I've actually looked in the folder to make sure. This is rejected based off of its height. It's very easy to reject this just because all these characters are a lot taller, and so it is rejected. So I'm going to count this as 1 miss because it thought that this M was 2 characters, so it missed it. So that is 8 characters. Moving on to the third Maryland. ZGV I65. So it missed the O or the 0. And that is, oh shoot. What was that? It was an 8. Okay, 9. So that brings our count up to 9. Make sure I don't delete my count before I know what it is. That defeats the purpose of it. So AJK2I6, it missed 1 here. So that brings us up to 10. KZT67Z is another one, so that brings us up to 11. It's understandable that it thought that a 2 was a Z. That's close. Moving on to Massachusetts. For EIP00, it thought that those were U's. So that brings us up to 13. Uh, 2652WE. So this one missed another 2. The Z or thought that the first 2 was a Z, and it thought that the W was an H. I think it's kind of interesting that it categorized one as a Z, or one of these 2s as a Z, and then the other one it got just correctly. Because looking at the binarized image, it looks like those are almost identical, but they're categorized very differently. So that brings us up to 15. 10787. So this missed 1. That brings our count up to 16. The 0 was categorized as an I. And it got the sample plate just fine. And then the last Massachusetts, I4CVIO, That is correct. And moving on to Nevada, it got the sample plate, no problem. (977 UUA), it got that. 599 MAR, that's good. 238324, that one's all good. J7L2E2 is correct on the last one. So what I found, and that's the end of my Python script that runs and through all that. So we missed a total of 16. We can do divided 16 and our 153. It did integer division. We missed roughly about 10% of them, 10.5%, which means if we do 1 minus that, oops, I need parentheses. Oh, what am I thinking? I'm not even in. Which means we read our accuracy for all the total characters was 89.5%, which is pretty good. It exceeds my requirement by 10% for those 5 plates. And yeah, thanks for watching my video.